Welcome to the second live class for Batch B of Advanced Python and Production Development. In this lesson, we are going to look at the different collection data types. We are going to look at the complexities that come up with this data type, how to loop through different collection data types, and then we're also going to look at how to use conditional statements in different ways. In week 1, we examined Python syntax, we looked at variables, and we looked at the different data types. Now we have the list data type, the set data type, we have dictionaries, and we have tuples. These are all container data types that we can use to save several values in one variable. Now, when we get to part 2 of this course, we will see that we have a module in Python called the collection module that we can use to simplify operations on this data type. Now, the collection data types in Python allow us to store these multiple items in a single variable, and so this way we can have more manageable or more efficient codes. Now let's look at the first one we call a list. Now a list is written using square brackets like this. So we can declare a variable, for instance, called, let's say, people. And this people will be equal to, within the square bracket, we are going to write our items as a comma separated list. Now the items can be of any data type. You can have number, any numeric data type. You can have a string that is quoted. You can have booleans, and you can have another list or another collection data type within this data type. So let's say we want a list of people. Let's say we want Jane, we want John, we want Martha, and we want Mark. So we have these 4 people saved in a variable called people. And let's say we want to also save their ages. And so the ages is equal to, let's say we have 23, 34, 45, 56, like this. This is how we create a list. Now we have this variable called people that stores the names of people. We have a variable called ages that stores the ages of these people. There is another way we can create this list. First of all, let's print this so we can see. So I want to print people, and let's print ages. So when we print this, we can see it's printed out as a list. There's another way we can create this list without using the square bracket, and we do that using the list constructor like this. So let's say we have people is equal to, and then we'll put the list, and then within the parentheses we will put the list items in a pair of parentheses. So we'll put another parenthesis, and then we want to put Jane, John, Martha, and Mark. So we can declare a list this way, and we can also put the ages the same way like this. We'll see that we'll print out exactly the same thing. So either of the 2 ways we can use to create a list, but the first method is always the best method. Okay. So the items in the list are indexed, and we know that indexing starts at 0 in programming generally. So the first item is at index position 0, the next is 1, 2, 3. So when you want to get the last index, the item, what index the last item occupies, you always want to check for the length, and you say 1 minus the length will be the last index, because it starts at 0. If you have an item of length 4, the last index position is going to be 3. If you have an item of length 5, the last index position will be 4. You can always check the length of a list using the length function. So let's print. In the parentheses, we are printing the length of people. And then we can see that people contains 4 items. And if we want to look at the last index of that, we can do print. And instead of having this, we can say people. We can print the index position. -1 always indicates last. In practical scenarios, you will not have knowledge of how many items are in the list in advance. So if you want to just see the last, you can just use -1 like this, and it gives you the last item in the list printed, which is Mark. If you want to know the last index of this, or you want to know how many index positions is occupied, or what index position Mark occupies, you can now decide to say you want to look at the length minus 1 of that length, because we can see that Mark is the last item there. So we're going to look at how to use different methods to do different things here. So the items in this list can be any data type, as we've seen, but we have two lists. We have one that contains only string and one that contains only numbers, but we can actually mix them up and have any data type. Let's say we have a longer list. For instance, let me add some items here. I'll add Alice, I'll add Bob, let me add Bob, Charlie, I'll add David and Eve, and then I'll add Frank. So I added more items to this list. Now that I have more items, I want to add more ages too. So let's add 2 for 6 more items, so add 6 more ages here. Let's reduce these ages to say this is 29, this is 15, this is 31, and let's say this is 42. Okay, so we have the ages for all of them. What we want to do here is to be able to see how we can select the range of values that we want to print out. So let's say we're creating a function, and what we want to do is to get something like we want items from index position, let's say 2 to 4, for instance. So once 0, 1, 2, we want to print from Martha, Mark, and Alice. So that's 2, 3, 4. We use slicing like this. So let's say we want to print people, and then the index position 2, but we don't specify 4, because the last index is always exclusive, it's not included. So you have to go 1 above to be able to print the last. If I put 4 here, what I will get now is Martha and Mark. Alice will not be printed because we say stop at index position 4. 4 is not inclusive. Whenever you slice like this and you specify your stop index, is not always inclusive, and so you have to go 1 above the stop so that you can print what you want. What we want is Martha, Mark, and Alice, and I will clear here, and I will get this printed: Martha, Mark, Alice printed. Like we looked at in the different string method, if you leave out the last index, it will print from index position 2, which is Martha, to the end. If you leave out the start index, it will print out from, let's use people, and let's leave out the start. So it will print out from the beginning to where you want it to stop. So let's say we want it to stop at Alice, we will say leave out the beginning, stop at 5. So when I clear here and we run, we're going to see what we expect. So print Martha to the end, because we still start from index position 2, and we left out the stop index, so it will print to the end of the list. We left out the start and we say stop at index position 5. It will print from beginning and end at Alice, because the last is not always inclusive. Okay, anybody with question?
Hello?
Yes, I can hear you.
Hello, ma'am.
Yeah, hello.
Hello.
Yeah, I can hear you. I can hear you now. Sorry, you are breaking. I think he has some network issues.
Yeah, I said the second print. Yeah, I guess it's the network. No, the line 5. The line 5.
All right.
We are printing from start to 5th index.
Yes.
Okay. And the 5th index stops at Alice. Okay.
No, the 5th index is Bob. But because the last is not always inclusive, the last is exclusive, you always have to go one above where you want to stop. We want to stop at Alice, which is at index position 4. But because we want Alice printed out, we have to stop at index position 5 because we know this is not included, so you can print out where we want it to stop. So every time you are printing out your stop index, just remember that the last index you specify is not inclusive. So if you specify index position 5, it's going to print out up to 4. So if you want to print index 4 out, you have to go to 5. If you want to print 5 out, you have to put 6.
I get it.
Okay. All right. So we can loop through a list using something we call a for loop, and we're going to look at loops later. But when you want to have something we call an iterator to be able to print out each item. Now, when we say we have an iterator, it's like we get any variable once. Let's name it anything. Let's say we want an iterator called I. And we want to say I is like, you want to hold a pencil, for instance, and you want to point at each item. And when the pencil touches each item, you want to print it out. So let's say I is the pencil we're holding, and we bring I to Jane, it prints out Jane. We bring I to John, it prints out John to Martha. And so we use a for loop to say for that iterator or that pencil, hypothetical pencil we have that we named I, we'll say for I in, and then we want to say for I in, let's say people, we want to just print I. So when the I, now hypothetically, I'm trying to give you kind of real life illustration so that you will know where I is coming from. So it can be anything, it can be X, it can be A, it can be B, it can be even a word like for person in people, print person. Because I use I like this. So whatever you want to use has your iterator. So just know that this iterator is like you have a pencil and you're pointing at each object. And when I comes here, you point at Jane, it prints Jane. When it points at John, it prints John until you get to the end of the list. This I is called the iterator that you have created. For and in and the keyword. For I in people. So for your iterator, in the name of the variable that holds the list, print I. So when we clear, it's going to print each item of the list like this. So one of the properties of a list, when you ask yourself, why do we use this different collection data type? How do I know when to use a list or to use a set or a dictionary or to use a tuple? The short answer is just use whichever one is easier for your use case. But we'll look at the different characteristics that will guide us to knowing what to use. Now a list is ordered. Because they have index position, you will see Jane is at index position 0. Except you use one of the list methods to change this position or to insert something at this position and it shifts Jane to the right, Jane remains at 0. And because it is changeable, you can use these methods to actually change the items of a list. This also allows duplicates. We can have another, for instance, Jane written here. Let's say we have, I want to use the same stuff back. I'll just leave the long list of items and just add more. So let's say I write Jane in lowercase and I write Martha in lowercase. So I'll use this to illustrate something later on. So it will allow duplicate items in the list. You can have a particular item repeated several times, but not all of these collection data types allows you to have repeated items or an item occurring once. Some of them want you to be unique, and we'll look at that as we go deeper. So you can have duplicates in the list, and these are the characteristics that guide you to know, okay, this allows all of this. For my use case, do I want to allow duplicates? Then at this point, if you are getting your data from a database, you know, especially if you want to load the names of people, you know that there are several people who might bear the same name. So you don't want to use a collection type that enforces uniqueness. So at this point, you know that I want to use a list instead of a set, for instance. So these are the characteristics that guide you to knowing what data type to choose for your different variables when you create them. Let's say we want to replace, let's say we want to replace Alice, for instance, with another name. Let's say we want to replace Alice with Sandra, or let's say we want to replace the item at index position 7 with Sandra. So let's say 0, 1, 2, 3, 4, 5, 6, 7. So we're replacing David with Sandra. I'll clear here and I will write the code like this. So if you want to replace, just get the index position and reassign a value to it. So say people 7, we want to replace it with from David to Sandra, and so we'll say Sandra like this. So before we do this, let's print people, and after we do that, well, let's just print people 7 so that we can just see what we want, and then after we do that, we'll print people 7. And so when we run this, we'll see that it was David, and after it is changed, it is now Sandra. So you can change it by reassigning a value to that position. We can also change a range of items instead of a single item. And let's say that we want to change the first 3 items. So the first 3 items are index position 0, 1, and 2. And you want to keep in mind also that the last index is not inclusive. So when you want to change index position 0, 1, 2, and we want to do this, let's write the code like this. We'll say, let's print people first so we can see when we change. And then we come to say people, we want to change 0, 1, 2. And then we'll say we're changing, well, let's print people at index position 4 for me to illustrate something different. And we're going to be saying we're changing people from 0 to 3. We say 0 to 3 because we want to change 0, 1, and 2. The last is not inclusive. We have to go 1 higher. So 0 to 3, like this. And what we want to replace them with is Jenny, Gerard, Megan. So 0, 1, 2. And let's print people 4. I will illustrate something now. I want to print this out for you to see what it prints out. Then I'll illustrate what happens when you specify less value than the range you have selected or more values than the range you have selected. So when we run this, at index position 4, we have Alice. And when we insert these 3, we still have Alice at index position 4. And we have said that the last is not inclusive. And I'm using 4, for instance, for to illustrate this because I said 0, 1, 2, 3. Let's print out 3 for you to see this properly. So at index position 3, you have 0, 1, 2, 3, you have Mark, and it remains Mark, illustrating to you that the last is not inclusive. In the event that I add another name here, let's say I add a new name here, Morgan, for instance. Now, at index position 3, we had Mark. But because I have put more values than the range I have selected, it is going to replace Mark with Morgan. So I'll clear here, and then I will run. And then the first time I have Mark, and the second time now I have Morgan. This is the only time that lists are changeable. When you insert something at the index position, it always shifts to the right, and the index position of the different item changes because everything shifts to the right. And when we print people, we will see that we've replaced the first 3 items, or the first 4 items now. So I'll just print people, and then we'll see that we've replaced the first 4 items, Jenny, Gerard, Megan, Morgan, because we removed Jane, John, Martha, and Mark. Okay? Mark was not removed. It was just shifted to the right because we had more items than the range we selected. Assuming we put 4 here, 0 to 4 here, it's still going to do exactly the same thing. Shifts to the right because we now want to or no, it's not going to do the same. It's going to delete Mark entirely because we have said replace the first 4 here. Let's do that and you'll see that this time we have Mark in the list, but the next time Mark is going to be deleted because now we have said it should delete Mark and we don't have Mark on the list here because we are replacing it with Morgan. Anybody with question?
No question for now.
Okay.
From my end.
Okay, there are several methods that we can use to add items and remove items from a list. Let's look at some of these methods. Let's say we want to insert an item into a specific index. Let's say at index position 2, where matter is. I'll delete this. So let's say where matter is, index position 2, we want to replace this with Katie, for instance. I'll just use something to say people dot insert, and then I'll specify the index position, which is 2, and then I'll put what I want to replace it with, and I said I want to replace this with Katie. And when I print this time, let's print people. I will have, we are replacing index position 2, and we have Katie here instead of matter. If we want to add item to the end of the list, we just use append. We have the append method. Let's say I want to just add an item to the end of the list. So instead of this insert, I'll use append, and I'll just specify what I want to add to the end of the list. Now when I print it, we're going to see that at the end, we now have Katie added here. If I want to add items from another list or any other collection data type, set, tuple, dictionary, to the end of the list, I have another method called extend, for instance. Extend. Unless I want to add the ages to the end of the list, like this. I will now have people.extend ages, and when I print people, I'm going to have the ages added at the end of the list, like this. So we have all the ages added at the end of the list. We have a method we call pop, and pop, we can use pop in 2 ways. We can specify an index for the pop to remove, or we can just say pop, and when we just use pop, it is going to remove the last item. So let's do this. We'll say people.pop, and let's say I want to pop 0. I want to remove Jane, and I'll print people. Now let's look at what this prints out. And remove Jane, it starts from John here because I use pop 0. But if I don't specify an index position to pop, we see here at the end we have matter, right? So I'll run this, and now we have Jane because it removes the last item when you don't specify any index to remove. We also have another method that we can use to remove items, just like the pop. We use the remove method, and we can specify what item we want to remove. Let's say I want to remove Alice, for instance. This is going to remove Alice from the list, and so we don't have Alice here. After Mark, we just have Bob next. We can use delete like this. Let's say delete and specify an index position. So let's say delete. So write delete first. It's a keyword, not a method or a function. We want to delete Jane. So we'll delete people 0. If you don't specify an index for delete, you're going to delete the entire list. So when you use delete like this, del, the name of the variable that holds the list, and then the pair of square brackets specify the index of what you want to delete. If there's no index specified, it will delete the whole list. So clear, and then we run, and we've deleted Jane. If we want to just clear the items of the list and insert a new item, we can do something like people.clear, and when we print people, we will have nothing in the list because we have cleared or emptied the list out, and so we have nothing in the list. If we clear and we print people and we say people.append Jane, we'll have only Jane in the list when we print people. So we have just Jane in the list. So these are the different methods that we have or that we use with lists to do different operations. You will need them when we start building our software for different use cases. If, for instance, we have, let's increase these ages to be the number of people that we have, so we can illustrate other methods. So let's say 42. How many items do we have here? I'll just add more items to hopefully be enough for the list item. Let me see the length to make it easier. Let's see the length and then adjust. So the ages is 71, so we have more. Okay, so they are now equal. So now what I'm doing here is I was trying to make the number of items in the both lists to be equal so we can illustrate the zip method. And when we use zip, what we do is zip is a function that we can use to combine two lists into a single list, but it's not going to be a list now. It's going to be a list of tuples that will return when we use the zip method. So let's say, for instance, I want to get the ages of each person, and we know that the index position in the people list and in the ages list are corresponding ages for the people. So those in the ages are the corresponding age of the people. So at index position 0 in the people, we have Jane. At index position 0 in the ages, we have 23. So we say that Jane is 23 years old. So if we want to now use this in any kind of function we're creating, we use the zip function. And so we can say something like people data is equal to, so we'll say zip, in the parentheses of the zip function, we'll put people ages. So these are the things we want to zip. And so when we print people data, what we are going to get is going to be a list of tuples. We're not going to get a list back. So let's say print people data. So we run this and we get objects at this. So we will not be able to get this. We're going to get the reference. So how do we get this printed out the way we want it? We can decide to cast this to a list, to say list, because we want it as a list. So say list zip people. So put that in the parentheses of the list function like that. So list will zip all of this, and then when we print it now, we'll get the list of tuples that we want to print out. So it now matches the names and the ages. So Jane is 23, John is 34. You can even use this in a statement, for instance, to say let's say for people ages in the people ages, we want to print a statement. Print, and here we use the format string to say people is ages year old, and this way we'll get the age of each person in a sentence. So we can see something like this: Jane is 23 years old, John is 34 years old. So these functions are powerful functions that we can use, and just see that in 2 lines of code we're able to write a statement that will loop through this and merge both the people and their ages. Anybody with question?
Hello, ma'am.
Yes.
Now, I want to ask a question.
Yes.
Now, I got to know that all of these, the list, the tuple, dictionary set, and the rest, they are under POP, right, ma'am? That's procedural oriented programming.
Okay.
And from what you told us the last time, that's oriented
object-oriented. Yeah.
Object-oriented programming. You said that is more robust, is more like it when it comes to Python, writing programming, and all of it. So I want to confirm now, if in an industrial environment where you want to write programming,
yeah,
are we still going to be referring to all of this, or we are going to base it on object-oriented programming?
Yeah, that's even an interesting question. Now, let me tell you something about Python. Python can be used in different ways. You can use Python in a procedural way. You can use Python in an object-oriented way. You can also use it in a functional way. Now, for those taking course 3, we are doing functional programming now, where we use Python in a functional way. And how are these things different? For you to know how they're different and which suits your programming or your software better. There is no best one. There's no one better than the other. If you are going to be creating things where you need to have a blueprint from which, just like we did object-oriented, where we have to create an instance of a class, we have a class person, and anytime we instantiate that class, we have a new person created, right? Those kind of instances, you know that object-oriented programming is the best way to do. But let's say that we want inputs to flow through a set of instructions, and what we want to do is we want to have more of functions, helper functions in our program, and these functions are going to be the functionalities of the program. Let's say, for instance, you are building a calculator. You want to use the functional programming method, because what you want to do now is create functions to say, if you press 2 times 2, you should run a function for product or multiplication. If you want to get the square root of something, you want to run a function that runs square root, right? So at this point, you are heavily using functions to just pass the inputs through it and gives the output, functional programming. So that's what makes Python very powerful, because there are different ways you can use Python. You can decide that you are building your software and you want to build it in a functional way, or you want to build it in a procedural way, or in an object-oriented way.
Okay, I get you. No problem.
Yeah. Okay. Any other person with question? We have seen how we use the len function to look at the length of, or the number of items in the list, and we can create iterables in a different way. Let's use the len and the range function in this example. We want to print, I will show you this first before I explain it so that you don't get confused. So let me clear this. So I'm going to say, for I in range, then people, we want to do something. Let's say we want to print people I is ages I years old. Now, what we're doing here is we're using the for loop, and we are saying the thing about the range function that we have is we use range to get something like let's say we have no data, for instance. We want to say for I in range 5, which means for I in, we have 5 items. We want 5 items. So we say range 5. We just use it to just create items on the fly like that. We're going to look more on the range function. So, but here I'm saying instead of range 5, so I'm using the length of the people, the length of this item, and the length is 42. So I want to say for I in range length people, or we can say for I in range 5, because when we look at the length of the people, it will give us the number we want, 42. So we want to say for I in 42 items in range 42, we want to say print people I is ages I years old. Now, this that we just did here is almost the same thing, or it gives us the same result as using the zip function that we just used. But how do you know which is more efficient? When we look at modules I think it should be in next week's lesson, we're going to look at how to use the time module to be able to see which code is more efficient, and then you choose for optimization purpose what method to use, or what function to use, or which way to write your code to achieve more speed and efficiency. So you can see this and the zip function does the same thing, and will print out the same thing. Okay. If, like we say, we want to get the index of an item, let's say we know that we have Bob in this list of people, and we want to find the index of Bob. We have a method or a function called index. So we can say print, let's just print people dot index Bob. And so when we run this, I'll clear. Sorry, there is an error here. Now this will not work like this. I have to say x is equal to people dot index Bob, and then I'll print x. So we are going to get an error with this Bob, and why I'm showing you this is you'll see how this is case list. They are case sensitive. Bob with lowercase like this. Let's do this. I'll clear here. The first method is correct, but I just want to show you something. Bob is with uppercase B, and when we run this, we're still going to have an error, value error. Bob is not in the list. Why are we having value error? Because this is case sensitive. How do we make this case insensitive? We can say print. We can do it the other way we did it before. Instead of using X, we can say print people dot index, and we'll say Bob, and let's see if we can use dot title, since it is in title case like this. And we still have the int object has no attribute title. So I'm using this for you to see, sorry, this is Bob, not Jane, for you to see that you can't have any escape to case sensitivity or case insensitivity of all of this. And this brings us to something called the sorting of list. When we sort a list, capital letters will be sorted first, and we've said that this is case sensitive. We're going to come back to this, and we just want to illustrate how case sensitive the items of the list are. You want to get the index position of Bob, you have to put it in the same case that this is. Now, because this is case sensitive, if you want to have like a case insensitive, first of all, want to sort, we use the sort function. We do something like, let's say people.sort, and when we print people, we will have this list printed out in alphabetical order because ascending is the default. If we want to change it to descending order, we just put reverse equal to true in the parentheses of the sort function, and then this time it will print it in descending order like this. When you are printing in ascending order, it will always sort uppercase letter before lowercase letters. You can see the lowercase letter appears last, regardless of what letter comes first. So uppercase letters are sorted first before lowercase. So when all the uppercase letters have been sorted, then now start sorting lowercase letters. The same thing for the reverse. When you reverse it, you take the lowercase letters first and then sort in descending order. If you want to make sure that this sort is case insensitive, then what you put here now is going to be key is equal to string dot lower. So which means that you are making this case insensitive by sorting this without looking at the cases of the different items in the list. So we can see now that it has taken the last two, Jane and Martha, and sorted Jane and Martha here where they're supposed to be with the other items here. So take note of sorting. And sorting is alpha. We sort in alphanumeric, or sorting can be done in alphanumeric way. These are little things that are not difficult, but they can lead to errors and a lot of confusion. So you want to take note of when you sort, the default is ascending order. When they're in different cases, it is case sensitive. When you want to sort in descending order, you use reverse equal to true in the parentheses of the sort function. When you want to sort case insensitive, you use key is equal to string dot lower like this. So you take note. If you are getting values from user input, and that's why you see when people are processing values, when we get to part 3 for course 2, when you get to part 3 of course 2, you will now see that when you collect user input from a form, you want to use one of these string methods, like convert everything to lowercase or title case before you send it to a database, so that things can be uniform when you retrieve, when you sort, when you do things like that. Anybody with question? Okay, if there's no question, let's look at one last thing before we leave this list. Let's look at how to use list comprehension. So we looked just recently at how we can loop through a list. Let's say for I in range, then people, and we printed this like this. Let's just say print people I. Let's make it simple. Okay, so when we print this out, we have the list of people printed out one after the other. This is one way of looping through a list. We can use list comprehension where we have, let's say for instance, we want to create a new list. Let's put this and say new list will now be equal to, the syntax is to write the expression first. The expression here is to print people I, the expression. So we'll say in a pair of square brackets, we'll say print people I. So what you want to do will come first. We'll say print people I like this, and then the next thing we'll do for what? The iterator is what to specify next. So print people I for I. Sorry, I'll put this. Print people I for I in. Now we want to put so we put the expression first, then we put the iterable, and then the condition. Now when you're using list comprehension, the condition must be evaluated to true. So print people I for I in range, then people. So we've written this in list comprehension form like this. So in one line we have this, and so we want to print new list. We don't even need to print new list because we have a print statement here. So I'm going to comment this out, and then we'll run this again to see that we'll get the same thing done like this. So we'll have the thing printed, everyone printed one after the other. So this comprehension can be confusing when you look at it. Just know the syntax is that you specify the expression first. What we want, the expression we have is what we want it to do, which is print first, and then we'll do the loop for iterator in the condition. So this will come first before this when we're using list comprehension. You have to practice list comprehension over and over again. If we want to just loop through, make it simpler, we can just do something simpler like print. Let's say we're printing I for I in people, and we can even put a condition, if condition there, but we're going to just print I for I in people. So let's see how this prints out. It's going to print out exactly the same thing, but it's a different way of writing this. So we have it printed out as a list like this. We're printing it out just one plain list. If we want to print it as strings, one after the other, we use other loop. Yeah?
Hello, ma'am.
Yes.
Yeah, sorry for interrupting. Hello?
Yes, go on.
Yeah. This for loop, I know we have a different kind of loop, right?
Yes.
I've not actually studied for loop very well, but the issue of iterator, I always get confused with iterator.
Okay.
I need to try to explain it the other time.
Okay. When you have a container type,
why I asked in the assignment given to us, that assignment 6.
Yeah.
There's something like that in question 1.
Okay.
So I just needed to throw more light to that. The iterator.
Okay. An iterator is just when we have a list like this container types, they're called iterables, right? And then when you have an iterable, you can create an iterator out of it. An iterator is just,
what do you mean by iterable? Is it countable or what? I don't get that.
Yeah.
Iterable.
So when you say this is an iterable, it's like it has several values in it, and you can transverse through the values. You can say, okay, let's say you have items. Let's say you have many cards. Now you have a flashcard. You have several cards, like 10 cards, and you put the cards on the floor, and you are teaching a child, and you take a ruler and you're pointing at each of the card and tell the child to tell you what is contained in that card. Tell you. So, like for those of you that have children, there'll be a time where you teach the child, you have flashcards, right? And you have A, B, C, D, E to Z. And sometimes you hold a ruler, and when you touch any, or you take your finger, and when you touch any of the card, you want the child to tell you what it is. Your finger or whatever you use to point at that thing is the iterator. That means your finger is moving from one card to another, and the child is telling you what it is. The child is now the print statements that is telling you, printing out the words that are on the card. Okay. Those cards now are the iterables because you can pick one card and drop it, and take another card and drop it.
Okay. So it's issue of grammar, right?
Yes, it's issue of grammar. It's issue of grammar.
Okay. Thank you.
All right. Okay. Any other person with question?
Ms. Fakoya, I'm not sure. Can you hear me clearly?
Yes, I can hear you clearly.
Okay, so the first new list is list comprehension.
Yes.
So the new list is list comprehension. Now this prints I for I in people. Okay, yeah. So I know you said I is the iterator, right?
Yes.
So I have 2 I's in this statement. So the first I'm confused. Why I have 2 I's in the statement?
Because the syntax is for you to specify the expression first, and the expression here is we're printing I first. So we want to print I, and then the condition for I in people.
In people. Okay, now I understand. All right. Thank you.
All right. Okay. So this is all about lists. You can research more and read deeper, but this is basically will give you a head start, or actually it's almost the full details about list. So let's look at another type we call tuple. Now, a tuple is just like list. The only thing is you define it using a round bracket like this. So you just change your square brackets to round brackets and you have a tuple for both. Now, how is tuple different from list? It is ordered just like list, but the items are unchangeable. Once you declare a tuple or you create a tuple, you cannot change the items in the tuple. So when you want to decide what data type to use, these are the characteristics that makes you know whether to use it or not. Let's say, for instance, we want to change items from index position. Let's say 0, 1, 2. We want to change the item 0, 1, 2. John, Jane. Jane, John, Martha. We want to change this. And we know that for tuples, we can't change. What you simply do is convert to a list, change it, and convert back to a tuple. So we'll say things like people is equal to list people. And then we want to say people from the range of 0 to 3. We want to change the items to be, let's add all their last names, something like that. And then we change it back to a tuple. People is equal to tuple people. And then when we print people, we have our tuple back. So this is the only way, workaround to changing items from a tuple. Every other thing we just look at in list can be applied to tuple. Just take note of how we declare a tuple. Is not square bracket, is round bracket. We can't add items to a tuple, and we can't change items in a tuple. We can only convert it to the list, change and convert it back to a tuple. That is the only way we can change stuff. Okay? When you want to declare a tuple and you have only one item, one thing you have to take note of is to put a comma. So let's say, for instance, I am declaring a new tuple. I'll comment this out. And let's say I have people is equal to, I'm going to append to it later, but I just have one person and I have Jane. If I put Jane like this, it's not going to be recognized as a tuple. For it to be a tuple, you have to put a comma at the end of it. If it's one item, just put a comma like you have more items, and then that is going to be a tuple. If we put like print, let's put print type of people. Let's do people is equal to Jane. So always just realize that you need to put a comma whenever you print type people. So let's illustrate this. So the first one is seen as a string because there's no comma at the end. When you want it to be a tuple, you have to put a comma after it, even if it's just one item. So you can see that we have the different types. And one is seen as a string, one is seen as a tuple. Okay? We can unpack, when we say we want to unpack tuples, like we have this tuple, people and ages. We want to say, for instance, we just want the first item of the tuple. We want to unpack this tuple, we want the first item. Let's say we want the last item also, or let's just say we want the first item and then we want the rest to be a list of tuples. What do we do to unpack this tuple? We do something like this. We declare variables that are the length of the tuple if we want to put each item saved in a variable. But in this case, I just want, let's say I want just the first item. I can do something like first, and then I will say asterisk others is equal to people. What this will do is that it will take the first item in this tuple and assign it to the first variable, and it will put all of the rest in these orders. We'll put an asterisk before this to show that all the rest of the items should be packed into one variable called orders. When we print first and we print orders, we'll see what it will be. So when I run this, we'll see that the first is Jane printed out by itself, and every other item will now be a list and packed as a list in a variable called orders. Okay, so in many practical instances, you'll need to unpack your tuple for you to be able to use them. So this is one way. So if you have like 5 items, you want to unpack them into 5 variables, you have to specify 5 different variable names equal to the name of the variable that holds the tuple items. And if you don't know the number in advance and you want to just get the particular one of interest, like the first one or the last one, you can specify variables for that and then use an asterisk in front of the variable that is going to unpack the rest as a list, like that. Okay. Well, the methods we apply to list, we can try them out with tuple. I'm not going to go into that because of time, but we have this method, the count method, that we can use to count the number of occurrence of a value. Let's say we have Jane appear twice. One is uppercase, one is lowercase here. We want to count the occurrence of Jane, for instance. So let's do this. Let's say x is equal to people.count. I want to count Jane. And then we print x. Now, take note of this. We've said that these are case sensitive because Jane is with uppercase, the other one is with lowercase, one is in title case. We only have one, although we have 2 Janes here because the casings are different. It picks this as 1. Okay. So every time you want to do this, you can decide to do people dots. You convert everything to one case first, and then you count to see the occurrence of that regardless of the casing. We also have another function we can use here, the index, that we can just use to get the index of the first occurrence of a particular value. Let's say people.index here. It will give us the index position of Jane here, and which is index 0. All right. So that's all about tuple. The other operations we did for lists and we apply to tuple, apart from the insert operations, because we can't insert into, or we can't change items in the tuple. The workaround is what I just showed you, to convert it to a list, change it, and convert it back to a tuple. So we have set, and sets are unordered, they're on index. And when we say set on index, well, set is just the same thing. You use a curly bracket instead of this round bracket. We'll change it. So you can see that the syntax is almost similar apart from how they are defined. So this one uses curly brackets, and this is a set. When do we even use set in real life? If I want things to be unique, I want them to be in a set. You can't put 2 the same items in a set. It's going to drop one of them out because it enforces uniqueness. The set is not ordered. It is not even indexed at all. You can never be sure what you will get from a set. If I print these people now, it will come in any order. If I print it the second time, it will come in any order. You will never be sure in advance what order, where the items will be arranged. So sets are unindexed, like this. So if you want something that is indexed, it's not the best thing to use. If you want something that is unique, you want to use sets. So if I print people twice, we can have them in all different order. So let's print people here. We'll do something. Let me clear. So we can see this first time Zach is printed, then Peter, then Mark, then Alice. But in this order, we have Jane, John, Martha. So you see how it's all different. Let me clear here and let me run this again. It's printed different. Henry is now first in the print list. So you can't be sure what order it will come. So you cannot tell anybody that the first position is Henry, because the next time you run this, you're not going to get Henry printed first. You get something else, and now we'll have Zach back first. So you can't be sure which order a set will come in. If I have a set of, I'll delete this. let me comment this out. Let's say I have things like, let's say brand, for instance, is equal to, if I have this brand in a set and I say something like, I'll list all of these brands, for instance, and I decide that I want to list a particular brand more than once. This is a very long, let's make this set very short so that we can see everything we're doing. So I want to list a particular brand more than once. When I print out this brand, it's going to drop anything that is not unique here because it enforces uniqueness. It's not going to see Apple as appearing twice. It's going to print out Apple only once. So if you try to convert to a list, add new item, the item are duplicates, it is going to still throw it out. So let's say we want to add a new item to this brand, for instance. We use the add method like this. So we can say brand.add and we'll add, let's say 1+. Let's try to add Apple again, or let's add Samsung. You will see that no new Samsung will be added because it already exists. Like that. So when we print brand, and we run, we will have just unique items printed out. It's not going to make Apple twice. It's not going to add the second Samsung. It's going to add 1+, however, here, because 1+ is unique. Now, another thing you take note of in a set is that it sees true and 1 as the same. It sees false and 0 as the same. So it will drop either true or 1. It will drop either false or 0. Both of them will not be able to exist at the same time. And so when we print, we will see that it will take, it puts true and false, it drops 0 and 1. Because it says true and 1 as the same, false and 0 as the same. We can use the update method to add a new set. So if we do something like instead of 1.add with one set, we can do brands.update and want to update a whole new set. Or I think we can also even add any of the other container types. But let's say we want to add new sets of stuff. We'll put Nokia, BlackBerry, all of them. We'll stop here. Let it not be too long. Sorry. Okay, that one's a very long list. I'm going to cut it short. So we specify a set of more items in the parentheses of the update method here to add more items here. If there's any duplicate, it is not going to add them. So when we print brands, we'll see that all of the new sets have been added in the other sets that we had. Okay, we use remove, and then in the parentheses of the remove, we specify what we want to remove. Let's say we want to remove 1+. We use remove like this. Then we can also use, but when we use the remove, we also have something discard that does the same thing. But the difference is that remove will raise an error if you don't find that item in the set. If the item does not exist, it will give you an error. When you use discard, if the item is not there, it is not going to raise an error. So if you want it to not give you any error, use discard. If you want to know whether the item is there or not, you use remove. Both of them will take out the item is specified in the parentheses from the list. Again, like we did in the list, if you use pop, it will remove the random elements. Now, in the list, we see that it will remove the last item if you don't specify an index. But for a set, you use pop, it will remove random item, and you don't know in advance which element will be removed from the set. And then when we use clear, like we did, you empty the list, you use delete, you delete the entire set. Sorry. Okay. And you see the way we use the zip function, when we want to do those kind of operations on sets. Let me uncomment this so I can illustrate this better. Okay, let's say we want to, for instance, we want to combine people and ages here. We have the union method that we can use here. Let's say we want to have people ages is equal to people dot union ages like this, and we will now combine items in both. Sorry, we didn't even print this. Print people ages. So we'll now have them combined in one set, but it's going to be in random order. You don't know in advance which order it is going to be combining. So these are the things that you want to take note on, or take note of. Okay? Anybody with question? So we have other methods that we can use here. We have, like, even this, instead of using union, you can actually do something like want to print, let's say, I think this should work. Without putting the variable, print people, you put a pipe ages like this. It should actually combine both people and ages in one set. Yeah, so we'll have them combined just like we did when we use union. Or we can have intersection, which will print the common element in both people and ages. Now we have no common elements, so if we say print, let's say people dot intersection ages. So what we want this to print is whatever is common between people and ages is what we want to print. So we use the intersection method like that, and there's nothing, so we just get an empty set return. Let's say, for instance, I put something like Jane here, and Jane is common to both of them. Then that's what we'll get printed out, because now we have something common to the both sets. We want to use difference. When we say we use difference, elements that are in people but not in ages, we can say people dot different ages like this, and we are going to print, it's going to print out the elements that are in people but not in ages. If we do print ages dot different people, it's going to do the reverse, elements that are in ages but not in people. We have something we call symmetric difference written like this, and when we use symmetric difference, let me delete this first. When we use symmetric difference, we are looking at elements in people or ages but not in both. When we want to check if there are no common elements, then we begin to use methods like is disjoint, or if let's try that. Print people dot is disjoint ages. So this is going to print false, because is disjoint is going to check if there are no common elements. And now because we have Jane and Jane here, if we didn't have this Jane put here, it's going to print out true. So let's see. So it's disjoint to print out false because the both of them have one common element, which is Jane. And when we use a subset, we want to see if all the elements of people are in ages, we'll just use a subset here. So if all the elements in people are in ages, you'll use this. And this is not going to print, it's going to tell us true or false. It's always going to print out a Boolean. If we use a superset, if all the elements in ages are in people, and if we want to add an element, we'll use the add method dot add. And if we want to update, dot update, like we saw in the other ones. Okay, so most of these things have similar methods that we use, just some unique methods that apply to only one type sometimes. So let's look at dictionaries. Now dictionaries are ordered and they are changeable, but the keys must be unique. They exist in key value pairs. It's written the same way we have the sets, only that each of these values must have a key or a name. Let's write a different type of data now. Let's say we want to have person 1. And person 1 is equal to, we declare a dictionary in a pair of curly braces like this. And then everything is going to be in name value pairs. Now, let's say we want to have first name. First name is John. And they exist as comma separated lists. So all of the values you have will be in comma separated list, but they must all be named. So now we have first name John, we have last name Doe, we want to have age, let's say age 30, and let's say we want to have email, something like that, email. And the email is, let's say, jodo@test.com. Okay, there has to be a comma after all of them. So we've created one dictionary item. This dictionary holds, this person 1 holds first name, last name, age, and email of a person. Let's have person 2 also, so we can illustrate things. So person 2 will have, let's just use almost the same. First name Jane, last name Doe, age 25, email, let's say Jane Doe @test.com. All right, and then we have 2 dictionary items. So you can see how dictionary is created like a set, only that all of the items have a key or a name. So we don't just specify items without a key. Now, if we want to add a new item here, all we can do is just to say, let's say we want to add phone numbers. So we can say person 1 dot. So we can use the update method to say person 1 dot update like this, and then we, in the pair of parentheses, we specify phone, and we put a phone number like that. Or we can just do something like person, let's use person 2 now. Person 2 dot, or person 2 in the square bracket, we specify the key, which is phone, and we'll specify a phone number for person 2. So let's just change the number up. So you can use either of this method to add a new value to this. So when we do this, let's try to print person 1 and person 2. So run this, and we have person 1 printed, person 2 printed. We have all of the items in the dictionary. If we want to print just not all of the dictionary items, we want to just print the first name of person 1 only. We can say person 1, and to get just the first name, we can say person 1. Let's do person 1 first name, or first name, and then that will print only the first name of person 1 instead of all of it, which is John, and the second one we're printing out all of person 2. We can also declare a dictionary in a different way, not this way, like saying let's say we're declaring person 3, sorry. So have person 3 is equal to, we can now use the dict constructor like this. Now, unlike the list and the set, we don't use double round brackets. We just use a single round bracket, and here we specify the key and the value. First name Sarah, last name Williams. We have age 30, and let's put email Sarah Williams @test.com, and then let's say we have phone now, and we'll specify a phone number Okay, so this is another way of creating a dictionary. If we say print person 3, we'll get it printed out there. So we'll have everything printed. We have methods that we can use to access the items. Apart from this method to say person 1 first name, we can actually use the get method. So I can say person 1 dot get first name like this, and then I'll say first name. It is going to print out exactly the same thing as just using that, and use dot get there. We can get all of the keys printed out by saying person 1 dot, let's say dot keys. So we know the keys. Sometimes when we're exploring our data that we get from a source and we don't know what the data holds in advance, we begin to use all these methods to be able to observe or study or explore the data. So when we say person 1 dot keys like this, let's just remove all these print statements. So we'll just print the keys. So we expect to see first name, last name, age, email, phone, and things as the keys. So we'll have all the keys: first name, last name, age, email, phone. We want to get the values, will be person 1 dot values like that, and this will print out all the values for the keys: John Doe 30, and all the values that are held in the different keys. If we want to return all the key value pairs, we can use this, I think it's items like this, and let's clear. And when we say person 1 dot items, it gives us the key value pair as a tuple printed out like that. So we have the key. So it's going to be a list of tuples having each of the tuple item is going to be the key and the value: first name John, last name Doe, age 30, like that. So take note of the data type that is returned when we use some of these methods. We want to remove item with a specified key. We use pop. And in the parentheses of the pop, we put the key, just like we looked at in the list. We want to remove the last item. So instead of using pop, let's see how to remove the last item. So I think we use pop item. So we'll say pop item, like we'll say person 1 dot pop item. You should remove the last item here, which is phone. And so when we print it out now, we will not get the last item there. We will get only what was popped out, which is phone. But if we say person 1 dot pop item before we print person 1 like this, then we will not get the phone printed, because when we print this, is going to print out what is popped out, the item that was removed from the dictionary. So let's run this and we'll see that the phone is not going to be part of it because it has popped out that last item. Okay, we use the delete DL to delete a specified key and the value, or if we don't specify that, it will delete the entire dictionary. Okay, and we've already seen how to looping through this always all the same. We can say we want to print all of the keys. Let's say this is a little bit confusing. We can say for I in person, let's use person 3 now. For I in person 3, we want to print I. We don't have a person 3. For I in person 2, we want to print I. So what this will print, what we expect this to print, is to print out all the keys, because I is going to be the key here. So when I run this, I have all of the keys printed. If I don't want to print the keys and I want to print the values, then I'll put person 2 and then the I in the square bracket here. So the I is going to be the index. So this time I'm going to be printing out the values. And if I want to print, there's another way we can print keys. We can just say for X in person 2 dot keys, print X. Or for I in person 2 dot keys, print I. Or we can say for I in person 2 dot values, print. We want to print key value pairs. We can say for I in person 2 dot items. I think we looked at items. We want to print So now because we want to print key and value, so let's say for ix in person 2 dot values, we want to print ix like that. So we'll print key value like that. So just play around with this to see how you can use all of this. We can nest this dictionary. And when we talk about nested dictionary is when you have a dictionary within a dictionary. That will be a little confusing, but let's look at how we can make it less confusing. Let's say we have a grade 9 class, for instance. And in this class, what we want to do is to list the subjects and their teachers. The subject is going to be a dictionary, and then the teacher and the classroom of the teacher, the homeroom of that teacher for that grade 9 class is what we want to do. So these are like real life practical examples. So I have a grade 9 class and I put it in a dictionary. I want to get all of the subjects for the grade 9 class. For each subject, I want to also get the teacher, the grade, and the classroom or the homeroom for that teacher. So let's put the subject now. Let's say mathematics. So mathematics is going to hold a dictionary of the teacher. Let's say the teacher is Mr. John, the classroom, A1, or the homeroom, and we can list the students too. That's going to be another nested dictionary, but this is just an example of that. But let's just stop on having 2 items here. Let's say we want the grade 9 to be a dictionary that holds a dictionary for the subject, and each of the subjects we want it to tell us the teacher and the homeroom for it. So we can put homeroom here instead of classroom. Something like that. And then we want to put the next subject. Let's put English. And then we want to put the item, the teacher and the homeroom. And then we want to list another one, science, teacher and homeroom. So these are practical examples. All of this must be comma separated list. Each of the dictionary within the dictionary must have a comma between them. So now think of a hypothetical scenario where you want to have nested dictionary like this. You want to have the key and the value. So you have other things like you can have family name like that, and you put first child, and the first child first name, date of birth, second child. So you can think of scenarios like this. Now when you want to access items in a nested dictionary, it gets a little bit tricky. It's not difficult, you just have to think carefully about it. Let's say we want to print out the name of the mathematics teacher for grade 9. So it's not going to be the same way we access the items. Let's first of all print out grade 9. So print grade 9. And then we want to print the name of the mathematics teacher. So we'll say print grade 9 mathematics. This is going to print out the dictionary, but we want only the teacher. So put mathematics in the square bracket, and then after it we'll put teacher. So we're getting the nested keys like this. So this, what we're expecting this to do is to first of all we'll print out the dictionary in the dictionaries of grade 9 to print out all of this, and then want to print out only the name of the mathematics teacher for grade 9. And then when I run this, we have the first one printed out all the nested dictionaries that we have here, and the second one just printed out the name of the mathematics teacher, Mr. John, for us. So when you want to access it, you access the same way. You just have a list of square brackets. If you have another dictionary within this, you just increase the square brackets to access each of the key like that. So the layers of nesting is the number of square brackets of keys that you specify. Is it clear?
Yes, it is.
Okay.
Yes, it is.
All right. So let's look at some kind of complex tags where this is applicable, because sometimes we learn these basics, but now tying it up together, and these are very powerful things you need to know before you develop your software. And in most technical interviews, you will need to use all of this. Now we use these container types, but when we get to part 2 for those in course 3, and then for those in course 2, I don't think we touch on the collection module. We will even see easier ways to work with these types using the collection module rather than doing things. For instance, we say we have, let me tell you this. We have something like, we want to look at the brands of different brands of cars, and we want to count the number of items in the list of the brands. Then maybe we want to look at unique items. So you are taking census population, for instance, and census of cars. You want to know the brands of cars in a particular city. And you stand on the road and you are taking the statistics of the brand. In maybe within 1 hour, you can get a particular brand and make of a particular car, drive past over 20 times. But you only need the unique value of that. But while you are there, you just keep listing what you see. And then later on, when you want to analyze or collect the data, you begin to look for the unique values. So this is one example. So let's use that as an example, brand. So we'll say brand is equal to, let's start with Audi. We have BMW. We have Mercedes. So I'll just use this list. So we have all of this list, and let's say we have some of them repeated. We'll say Audi is repeated. We have Honda repeated. So we have some of them repeated like this. Now we have all of these brands of cars, and we want to count the number of items in this list. We use the len function like we already know. If we want to count the number of unique items here, we already know that the set data type enforces uniqueness. So the best way you can do this is just convert this to a set if you're not using the collection module. So we want to do this, and we don't want to use the collection module. And so we want to convert this to a set and then count the items. So we can say brand is equal to set brand, and then we'll print len brand. So now we know exactly the number of unique cars that we have, because all we need to do is to convert it to a set, and we say 10. But if I print the length of brands before this, we don't have 10 items. But we have 10 unique items. So we have 12 items, and then we have 10 of them are unique, because I added Audi and Honda twice. So it took out the duplicate. So when you have assignments that tells you you have this list of items, and we want you to write a function that tells you the unique number of items there, this is just what to do. One line of code, convert it to a set, and it gives you the unique number. Okay? If, let's say, we want to count the number of times that each item appears in the list, and we don't want to use the collection module, we just want to do this, maybe create a function or do this without a function, then at this point now, we want to maybe create an empty set and then count the number of times it exists. Let's try to do that. So we have brands. Let's say we have something called brands count, for instance, and this will be equal to, now counter is a collection module that would have just done this in a short way, but we're not going to look at that. So we do create an empty, we create this variable brands count that will hold the number of times each item appears, and maybe we want to use it as key value pairs like a dictionary. So we'll create this empty dictionary like this, and then we'll say for I in brands, we want to say if I is already in this brands count, we want to increase the number of it, like the frequency, else we want to set it is equal to 1. Let me see a simpler way of explaining what I just wrote here, and this would have been easier with the collection module. With the collection module, we'll just import collection, and I won't touch on that now. I will use the same example to see how we can actually use inbuilt module to make this simpler. Okay, so we have the create an empty dictionary. We want to put them in key value pairs, right? And the iterator I which we want to hold as the key. Let's print this out so you see what it prints out before you understand what I'm doing. Let's print bronze count. So we have Audi, so 2 BMW, 1 Mercedes, 1. So what we are using now, we're using the name of this brand as the key, and the total number of occurrence as the value. Recall when we looked at the dictionary that we get the key by saying, let's say brands I, where I is the key, and when we use brands I, it becomes the value. So I becomes the key, right? And then this becomes the value. So now we are saying the iterator I in brands. If I already exists in this dictionary, that is the value I, so the I is the iterator, which makes it the value. If it already exists here, if that value already exists here, we want to increase it. This is just same thing as saying increase the value by 1. If it doesn't exist, set the value to 1. I don't know if this is explained, if you understand this. Because when we say for I in brands, now we're iterating through these brands. I is the iterator. And so when we get I comes here, it checks this dictionary first to see if it has touched on this previously, just for the sake of duplicates. If it has, increase the frequency by 1, so set the value to 1. So this is going to be the key. If it has not seen this value before, just set it to 1. So this loop, or this loop and the conditional statement within this loop is going to make sure that we increase the frequency count, and this loop is going to make it loop through all of this and now set what is going to be within this. And when we print it out, we'll see that we have the dictionary where the brands are the keys, and then the value is the frequency for the number of times that it exists. Anybody with question? Okay, so we have conditional statements that we keep looking at, if and else, but in Python we have different logical conditions that we use to do something based on a condition. Like we use this equal to see if something is equal to another. We use not equal to, exclamation mark equal to say if something is not equal to something. We use less than, and we use greater than, and then we also use less than or equal to, and then we use greater than or equal to, like this. So look at different conditions. So let's have, for instance, x is equal to 10, and then we have y is equal to 8. We want to say if x is greater than y, we want to do something. So in this scenario, we're just going to print out. So if x is greater than y, we want to print out x is greater than y. If we want to have another condition to check if this first condition does not evaluate to true, we use an elif statement like this. So elif x is equal to y, we want to print x is equal to y, x and y are equal, and then we will, if that is not true, we will print x is less than, or y is greater than x, or x is less than y. So we are seeing how we can use this conditional statement to say we can specify several conditions. If we use the if statement and we want to have another condition to check if the first one is not true, we can do elif. Can you have multiple elif to keep checking if one is not true? But if you want to check different conditions regardless of true or false, you can just keep using if statements. If you want to have like a control flow to just check one before checking the next, so if this condition is true, it doesn't bother checking anything below it. If this is not true, then it checks this next statement. If this is not true, then it prints what is in the else block. If this is true, it prints this and just exits. Okay. So there's something we call ternary operator, and it's just like writing all of this condition in like one line of code. We do that a lot in programming. Sometimes it's more elegant when you do it in programming language like PHP. But let's try to do the same thing using ternary operator, or a different way of doing this. So I'll put the condition first. I think this is what I'll do. I'll say print x is greater than y. If x is greater than y, else I'll print x and y are equal if they're equal, and y is greater than x if that is not the case. So like this whole thing, I have put it to do the condition first, do the expression first, then the condition, then the expression, then the condition, then the expression, and all of this will still print out the same thing I printed previously, but I put them in one line of code like this. So x is greater than y. And when I change x and y to be equal, we'll see to print something different. X and y are equal, and if I put y to be greater than x, and I'll see that y is greater than x. Okay, so you can do them on one line like this. If it's confusing, you can just stick to doing it this way. So when you do it on one line, you just use if and else like that. Any question? So let's look at how we can do this loop. And when we loop, we want to see how we can use break and continue statements, and even pass statements within a loop. Let's say I want to loop through. I'll just create something within a range. So like we have said before, that we can use the range function to generate a sequence of numbers, and I want to generate numbers from 0 to 4. So I'll say for I in range 0 to 4, that's 5 items. So I'll say for I in range 5, I want to do something. So for I in range 5, I want to just print I. So it should print 0 to 4. Like this. So when I run this, I'll print 0 to 4 to the screen. Now, this is using the for loop. When I use the while loop, I have to use this when, for instance, I don't know the number of iterations beforehand. Like, let's say we set I equal to 0 now. And then I'll say, while we used 5 the last time, right? While I is less than 5, I want to do something. I want to print I. And then you have to increment. If not, this is going to continue infinitely. So while I is less than 5, I print I, increments the value of I to be 1. So this is the same thing as saying I is equal to I plus 1. So increments the value of I to be 1. Then it checks it again, increments the 1 until I becomes less than 5. So it will increment this value by 1. It will still print out 0 to 4 for us. Now let's say we go back to using our for statement or for loop. So we'll say for I in range 5, we want to, let's say for instance, we want to say if it meets the number 3, it should just stop, break, or exit the loop. That's when we use the break statement. So we'll say something like if I is equal to 3, we want to break. So this will just break out of the loop or exit the loop completely. And then we want to say print I. So it will print 0, 1, 2. Once it meets number 3, it just halts the program. Okay? So this is how we use the break statement. We don't want to see number 3. Everything until it meets that number 3. But if what we want to do is not halt, but we want to skip, we can now use continue instead. So if we use continue here, let's use it and see. So continue like this. And then when I print this, it's just skip number 3 and continue printing the next items. if I want to say I'm writing an empty loop, there's nothing I want to put for now. I don't know what to do here now. I can just put pass. Every time you say a pass statement, it's just like we don't want this thing to error out. We just want to create an empty loop. So then I say if I is equal to 3, pass. That means it's not going to do anything. This will not affect. It should just still print out our 0 to 4 for us. Because now I can't decide if I want to break, if I want to continue. So I just put a placeholder here, pass, so that I won't have an error. So anytime you see pass, you create something, you don't want to do anything, it's empty, you put pass. Okay. So we can have a nested loop like we want to print. Maybe let's say when we start doing things like factorial, but let's say we want to print like 0 0 0 1 0 2 1 0, like we want to nest two numbers together. We want to see the number of times like we do in when we zip. So let's say for I in range, let's use 10 now. Let's see how long it will be. For I in range 10, then we'll nest another loop now to say for J in range 10, we want to print I J. So this time to print because this is 0 to 9, so it will print 0 0. So it will take the first one and match it with all the items, second one and match with all the items, third and match with all the items. And so we're just going to get the items for the two together, just like we'll see when we use the zip function. So now we have this printed 0 0 0 1 0 2 0 3 0 4 0 5 0 6. So this is one example of using a nested loop. So does anybody have any question? So in the absence of questions, I would rather we stop here, and then when we meet on Friday, we will look deeper at using the collection module for this and look at other topics that are of difficulty to most of you. Okay?
Thank you.
Okay, thank you.
All right, thank you.
All right, bye.
Bye.